Hey everybody! The last idea we're going to be talking about in this course is electromagnetic waves. Electromagnetic waves have an interesting property that we haven't really talked about before. It's called polarization. An electromagnetic wave is exactly what it sounds like. It's a wave created out of electric and magnetic fields. These fields oscillate at right angles to each other. So for example, if there was an electromagnetic wave traveling from me to you, the magnetic wave might wiggle up and down like this, while the electric wave wiggled left and right like this. However, we could also imagine the opposite scenario, where the electric wave is oscillating up and down, and the magnetic wave is oscillating left to right. For the most part, these waves would be the same. They could have the same brightness, they'd be traveling in the same direction at the same speed. But the difference in the direction that the individual waves are oscillating turns out to be measurable. And in fact, we can actually create materials that are able to filter one or the other type of wave out. I have here polarization filters. They do exactly that. Think of the electromagnetic wave, where the electric field is oscillating up and down, as a vertically polarized wave, and the wave where the electric field is oscillating left and right to be a horizontally polarized wave. A polarization filter is able to filter out one of those two types of waves. Visible light is an electromagnetic wave, and so polarization filters will work on it. What I'm going to do now is turn the camera up towards one of the lights on the roof, and we're going to see how a polarization filter can affect that light. Let's start by seeing what happens if we place a single polarization filter between us and the light. As you can see, the light gets dimmer, but no matter which way I rotate this polarization filter, there is still light that passes through. Why is this? Well, it's because the light from this lamp is not polarized. So no matter which way we turn the polarization filter, some of the light will be filtered out, but not all of it. What happens if we place a second polarization filter? Well, at first, nothing happens. This is because I've placed the second polarization filter in the same orientation as the first. The light travels through one polarization filter, which filters out all the light that is not polarized in a particular direction. But because the second polarization filter is oriented in the same direction as the first polarization filter, all the light that passes through the first is also able to pass through the second. But what happens if we slowly rotate the two polarization filters with respect to each other? Notice that as we rotate, the light gets dimmer and dimmer until when the polarization filters are at exact right angles to each other, the light is blocked out entirely. When the two polarization filters are at right angles to each other, all the light that passes through the first polarization filter is unable to pass through the second polarization filter. Let's see what happens if we add a third polarization filter in between them. Now you might be thinking, there already isn't any light passing through these two filters. So how could adding a third filter do anything different? Well, let's see what happens. Hopefully you can see that there's a small amount of light that's now passing through the filter. So there were two polarization filters that didn't allow any light through. And when we added in a third polarization filter that was at an angle to both of them, all of a sudden, light was allowed to pass through. So what on earth happened here? Well, when light passes through a polarization filter, all of it is polarized in the same direction as the polarization filter. So for example, this polarization filter might filter out all the light that is not polarized in the vertical direction. If we place the second polarization filter at a right angle, it's going to filter out all the light that is not polarized in the horizontal direction. But once the light passes through this first polarization filter, it is all polarized in the vertical direction. So a polarization filter that only allows through light that is polarized in the horizontal direction won't allow through any light because there is none that is polarized in that direction. But if we place another polarization filter between them, it's going to allow the light through that's polarized in this direction. If you have light that's horizontally polarized, some of it can also be thought as being polarized in this direction. And if you have light that's polarized in this direction, some of it can be thought of as being polarized in this direction. That's why you can have two filters that don't allow any light through, but add a third filter that lets a little bit of light through.